Morning, children. Today we are going to see how to prepare the alkyl halides by using several techniques. Just you know that generally the chemicals which we are preparing by refluxing method, by heating method, by using many reagents, that the chemicals are to be prepared from one substances to another substances, that and also generally many preparations are based on only the alcohols. The alcohols are the fundamental compounds which are the starting material for synthesizing of all compounds. First of all, which we are going to see here, the preparation methods, that is methods of preparation of alkyl halides, methods of preparation of alkyl halides. The alkyl halides are nothing but alkyl. You please understand what are called alkyl groups. Alkyl groups. This is methyl. This is ethyl. This is that profile CH3, CH2 bond profile. This is the butyl CH3, CH2 bond. This is profile. This you want, right? One carbon is methyl, two carbon is ethyl, three carbon is propyl, and four carbon is butyl. These are all the alkyl groups. Alkyl, alkane. These are all derived from alkane. That methane, ethane, and propane, and butane. These are all, that is the alkane. From alkane, we have to prepare alkyl, that absence of a nitrogen. One absence of a nitrogen. This we can represent it as alkyl groups. With that alkyl groups, there is a bond. This is the bond, pair of electrons. The bond is nothing but it is in a pair of electrons. This pair of electrons are waiting to have to substitute with it the halogens, that is halides. You know that halogens. What are called halogens? Which are shortly we can represent as X. The X is equal to fluorine, chlorine, bromine, iodine. This is the point. Children, now we are studying about the preparation of alkyl halides. First of all, you should know about what is called the halogens. The halogens are called salt-producing elements. Salt, halo means salt-producing. Like a sodium chloride, the salt, which can be produced by halogens. That is, salt-producing substances are called, we can say, halogens. The halogens are nothing but, that is, fluorine, chlorine, bromine, iodine. Now, this is all going to substitute with this. If there is a methyl with fluorine, methyl fluoride. The methyl with chlorine is called methyl chloride. The methyl with bromine is called methyl bromide. The methyl with there is iodine is called methyl iodide. This is structure. You see here CH3 methyl fluoride, CH3 Cl methyl chloride, CH3 Br methyl bromide, CH3I methyl iodide. This is the point. The concept of this is alkyl, this is halide. So it is called alkyl halides, which are called alkyl halides. Now you take here C2H5, there is of C2H5, that is chlorine. C2H5, that is bromine. C2H5, that is iodine. Now you see, this is called ethyl fluoride, ethyl chloride, ethyl bromide, ethyl iodide, that is ethyl iodide. So these are all called, we can say, alkyl halides. How do we prepare these compounds? How do we prepare these compounds? By using the chemical methods. What are the chemical methods which we are using to how to prepare these halogens? You, for example, that you can take this profile group. This profile is to be attached with it. There is a halogen fluorine. This is profile fluoride. There is bromine. There is chlorine. There is iodine. Now you see profile chloride, profile bromide, profile iodide, profile fluoride. So no branches here. We write N profile. There is no branches here. We can see it is N profile. N profile, N profile. So next we are going to see here the next concept. How do we prepare these all compounds? How do we prepare these all compounds? Preparations. First of all, that I have told that very clearly, the starting material for the preparation of halides by using alcohols. That is the alcohol, you know, this is CH3OH. If there is a OH is present in organic group, this is alkyl groups, organic, alkyl group, OH is present, which are called as alcohols, alcohols. The OH is attached, but the same OH is to be present in inorganic substances, inorganic substance, like NaOH, is it? KOH, which are called alkali, alkali. These are all base, strong base. But here, the point you should understand, the OH which is present in alkyl groups are called alcohols. Alcohols. That you know, what are the types of alcohols? That is the point you should understand. Methyl alcohol. Ethyl with ethyl group, that is ethyl alcohol. Then propyl alcohol. This is propyl alcohol. This is with OH. And here this N-profile. I can give isopropyl. That is the point you can write isopropyl. That is with OH. This is CH3. This is, you see, alcohol. Methyl with alcohol, methyl alcohol. Here, ethyl with alcohol, which are called ethyl alcohol. And propyl with alcohol, that is N-profile. That is N-profile alcohol. And here, this is called isopropyl. This group is called iso. Why it is called iso? The concept you should know. The same alkyl groups CH3, CH3, CH. These two groups are same. Iso means same. Same. That is a Latin word. Iso means same. The same groups are present. This one carbon atom. Two same groups are attached with one carbon atom. Now this carbon atom is containing OH. This is iso. Three carbons are, we can say it is propyl. If there is a three carbon, we can say propyl. This is isopropyl alcohol. Why we can say it is alcohol? Due to the presence of OH. There is a OH alcohol. There is a three carbon propyl. There is a same alkyl attached to this carbon iso. This is a simple method to how to naming that compounds. That you know. And these are all the alcohols which containing OH always, you know that. This OH to be replaced OH to be replaced. This OH to be replaced by halogens. By halogens. What are halogens? Fluorine, chlorine, bromine, iodine. We have to replace. This all OHs are replaced. Now the compound that you see here, the fluorine is being replaced. This OH. Now you will get that is CH3F. The chlorine is replace means removing. Removing. Chlorine is removing this OH. This will give, this is the concept you should understand. This is CH3Cl. This Br is removing this OH. Now the compound is, we can write CH3Br. That you see, the OH is removed by replaced by iodine. Now the compound is called CH3I. That is methyl fluoride, methyl chloride, methyl bromide, methyl iodide. So it is an easy method you have to prepare the alcohol, that is the alkyl halides from alcohols. It's a simple concept. Next we are going to see here. The next methods, the preparations. The first method, preparation of alkyl halides This is the first method from alcohols. You take alcohols. What are the types of alcohol? You know that alcohols are further classified into primary, secondary, tertiary alcohols. Primary, secondary, tertiary. Primary is nothing but CH2OH. Some is the exceptional CH3OH. Secondary means CHOH. The alcohol to be attached with CH carbon and with two alkyl groups or. That you know the tertiary is nothing but the C carbon is attached with the three alkyl groups. This is the point we should understand. Primary, secondary, tertiary. Now, the preparations of alkyl halides from alcohol. First of all, I want to take that is the Lucas method. The Lucas method is highly reactive with the tertiary alcohols. So first I am taking tertiary alcohol. You know that CH3, 3 alkyl group with the COH. This is tertiary alcohol. And this tertiary alcohol is treated with that concentrated hydrochloric acid and anhydrous AlCl3 is a reagent. This is anhydrous means that it is to be this AlCl means you can write zinc chloride. You write now zinc chloride, anhydrous zinc chloride. Zinc chloride that you see here, anhydrous zinc chloride, that is anhydrous ZnCl2. Now you see here that which containing chlorine, that here which containing OH. What will happen? This chlorine is going to substitute here. This H plus reacted with the OH minus. This forms as OH minus. Now what happened? H plus and OH minus, which gives H2O as in a water, elimination of water, removal of water. Finally, what is the product is obtained here? CH3, 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 then Cl. This is, you see, tertiary alkyl halide. What's the name for this compound, children? Tertiary, that is tertiary alkyl halides. Is nothing but tertiary alkyl halide is nothing but tertiary. 4 carbons are there. 1, 2, 3, 4 carbons. So it is butyl. So you write now the name of compound is tertiary butyl, tertiary butyl chloride. Tertiary butyl. You see, alkyl. What kind of alkyl? 4 carbon is there, which is called butyl. See, halide means what? What halide is here? Chlorine. So chloride. So tertiary is the common. Why? Because this carbon is called tertiary carbon. Now, this is the simple methods by using Lucas reagent. This reaction is taking place immediately. This reaction is immediately taking place. Now, you take the reactions. Next, the secondary alcohol, how do we, that is secondary alkyl halides, how do we prepare? By using secondary alcohol, you take CH3, CH, OH, CH3, same reagent. You can take, this is what? Concentrated hydrochloric acid, same anhydrous ZnCl2. Now what happened? The same thing, OH minus, H plus, this all together reacting. Then Cl minus is here, which is going to approach this carbon. This will become positive charge after gaining of this pair of electron by this OH. Now what happened here? H plus and OH minus. The elimination of water, that is plus. Cl minus approach here. What will be the products? Now you write CH3, Cl, then CH3. Now what happened here? This is secondary group. It is secondary group. So it is secondary alkyl halide. It is nothing but we can write isopropyl. This is chloride, you know. So write isopropyl chloride. This compound is isopropyl chloride. This reaction is not immediately taking place. This takes place after 5 to 10 minutes. After 5 to 10 minutes. The reaction which is taking place after 5 to 10 minutes, we could understand about these reactions by forming turbidity. By forming that, you know, if you are taking the reactions, that you take the test tubes. Now you take that alkyl halides. Just you take here that you are taking alcohols. OH is present. Now we are pouring here that HCl and anhydrous ZnCl2. This is all pouring inside. Immediately the reaction takes place. We can understand by knowing our eye. Just we can look this reaction and immediately turbidity is nothing but it is that there will be the change which is occurred in these reactions. Turbidity is changing and forming after 5 to 10 minutes. We should understand the reaction is taking place inside this. The same reactions I can take with the primary alcohol. This is that CH2OH is a primary alcohol. You know that which is CH2 is primary carbon. With this the primary carbon, alcohol is attached to this primary alcohol. Now the same reagents I am taking. What is that? Concentrated hydrochloric acid and anhydrous Cl2. I am taking now. What will happen? The same reagents. The alcohol is pouring into the test tube, and here the hydrochloric acid. And what happened? There is no reactions which is taking place. There is no reactions with the primary alcohol, but the reaction is occur after you are heating the tube. Test tube, you have to heat it. What will happen? The reaction will take place. What's the product which is going to give? That is the point you should understand. There is at room temperature. What's the entrance question here? What is the entrance question here? Entrance question. What is the reaction which is taking place at ordinary temperature, or there is to be at heating? That is a question. And here the primary alcohol is not reacting at this ordinary temperature, or we can say room temperature. This is a twist, you can understand. This reaction is not takes place at room temperature. By heating these reactions, now you are getting that what? Ethyl chloride, the same OH is replacing, the same H plus is reacting. Now finally what is eliminating? H2 is eliminating, that is H2. Then what is eliminating? H2 will be removed. And what's the reaction? This is ethyl chloride. Is nothing but we can write this is ethyl group, which chlorine, ethyl chloride. This is a point you should understand here. Next we are going to see here the second method. The second method, that is a preparation of tertiary butyl iodide. How do we prepare this tertiary butyl iodide? This tertiary butyl iodide is prepared from tertiary alcohol. You know that what is tertiary alcohol? CH3. This is tertiary carbon with OH. Tertiary alcohol. Now to treat with that hydrogen iodide. This is hydroiodic acid. Like HCl. HCl also acid. HF also acid. HBr also acid. HBr also acid. HI also acid. These all acids are having ability to give the H plus ion. Now this is that OH minus ion, H plus ion all together reacting. Then finally what happened? That elimination of water. That's all. Then apart from that, the reaction which is not takes place at ordinary condition, we have to use some catalyst. Generally, chemical reactions takes place in presence of catalyst, in presence of heating. These are all the general methods or general techniques while we are proceeding the chemical reactions. To take for example, I can take Ka as a catalyst, and also to how to promote the reactions. Phosphoric acid, H3PO4, ric acid, phosphoric, not phosphorus. That you see, phosphorus, H3PO3 is called phosphorus acid. That you see, if there is a 4 is present and phosphoric, this res and ric is based on the oxidation number of the phosphorus. Phosphorus oxidation number is changing, the characteristics of the acid will get changes. Now this is a promoter and a catalyst which we are using. Finally, the iodine is become as I minus. This will go to approaches to here. The product form is called, we can write CH3, I. This you see 1, 2, 3, 4 carbons are here. So which is called butyl. So this carbon is tertiary. So it is tertiary butyl. This iodide is here, that is halide. Iodide is here, that is halide. Now you tell this is what? Tertiary butyl iodide. This is a point. This is a point. The next method we are going to see here, third method. And this, before we are going to study about this third method, and we are going to understand about what are the reactivity orders. Reactivity order means, and here HI is an acid, and which is having greater reactivity than that of HBr, than that of HCl, than that of HF. This is the entrance question. You please understand. What is the reactivity order of the halogen acids? The HI is having more reactivity than that of. Why? Because the iodine is bigger in size, its atomic size is bigger. And here having which is I minus is negative charge. We are also, this is also to be the greater in size than that of bromine, than that of chlorine, than that of fluorine. And here this is haloacids reactivity, haloacids and its reactivity. Now reactivity of alcohols. Alcohols also, which alcohol is having more reactivity? Alcohol's reactivity. Reactivity is nothing but the ability of reactions, how fast the reaction is taking place. How fast the reaction is taking place. That is reactivity. Tertiary alcohol is having more reactivity. That is R with OH. That is, you see, carbon valence is 4. 1, 2, 3, 4. 4 valency. This is tertiary alcohol. Shortly you can write tertiary. Then you write secondary alcohol. Or this is secondary alcohol. Then we can go for primary alcohol. That is primary alcohol. This is alkyl or OH. This is 1R with OH, primary, 2R with OH, with the CH carbon, secondary, 3R with the C carbon, tertiary. And here in this type of reactions, which is having more reactivity, tertiary alcohols are having more reactivity than that of secondary alcohols, than that of primary alcohols. This is that reactivity order. This also the entrance question. You please understand what's the reactivity order of that alcohols with the haloacids. Now you write this is having more reactivity order. Now we are going to see here the next preparation methods. What is here? The third methods. That is by PCl5. You know that? Phosphorus pentachloride. That is third method. Please understand. Now children, we are going to see the third preparations. Now the third method, which are all very easy reactions. You take any alcohols, not only these primary alcohol, you take any alcohols. Now I am taking primary alcohol, that is called ethyl alcohol. This is ethyl with OH. It is called ethyl alcohol. Ethyl with OH. Ethyl with OH. This is ethyl alcohol. Right. Now I take this PCl5, that is PCl5. This phosphorus pentachloride can split as PCl3, Cl and Cl. Now you see this alcohol, this PCl5 is nothing but we can say halogenating agent. Halogenating agent. This alcohol is halogenating agent. That means halogenation is nothing but adding an addition of halogens. Halogenating agent. Addition of of halogens, which is having ability to add the halogens into the alcohols by heating process, by using P-sulfide. This is phosphorus pentachloride. Now this chlorine is going to approach here. Then what's the product? You write CH3, CH2, Cl. Now you write the product CH3, CH2, Cl. This is called what? Ethyl chloride. Ethyl chloride. Then plus, what's the remaining thing? One oxygen, one PCl3. Now you write POCl3, phosphorus oxychloride. Phosphorus oxychloride. That is the point you should write. And here this one hydrogen with one chlorine. What happened? This one hydrogen with one chlorine, which forms as a HCl. That's all. What is the reaction here? Third method, preparation of alkyl halides. What's the product is? Alkyl halide. What is the name of alkyl halide? Ethyl chloride. Now what is that? POCl3 and HCl. Now we are going to see here the next method, that PCl3. PCl3. Now we are seeing here that the same reactions with the PCl3. This is phosphorus trichloride. How do we use this? This is fourth method. Phosphorus trichloride. Now you take the same ethyl alcohol. I can take phosphorus trichloride. This is 3 chlorine. Now you take 3 moles of alcohol. If there is 3 moles of alcohol, 3 moles of alkyl, 3 chlorine, all together which is giving the product, you see, 3 alkyl, 3 alkyl. Then with the 3 chlorine, you write here 3 chlorine. Equation balance. This is ethyl chloride. What is called ethyl chloride. This is what? Alkyl halide. Now we prepared. That's all. Now what are remaining? You see here 3 hydrogen, 3 oxygen, 1 phosphorus. All together, which is giving, you see, 3 hydrogen, 1 phosphorus, 3 oxygen. Now which is called phosphorus. I told that before itself. This is called phosphorus acid. Phosphorus acid. Now this form is called phosphorus acid. Now there are methods. Next is the 5th method. We are going to use sulfurous chloride, SOCl2. It is also kind of chlorinating agent. Now you take the same alcohol CH3, CH2, OH. Then plus you take sulfurous chloride, that is thionine chloride, that is thio means sulfur, that is thionine chloride. That is the reaction. SOCl2 is taking here. What's the product? You can get it from here. You see. Now, what is the aim? You please understand. Alkyl halide is preparing. Now, chlorine is substitute here. How many chlorine here? 2 chlorines. 1 chlorine is reacted with the hydrogen. 1 chlorine is reacted with the alkyl halides. That is alkyl group. Now it is forming is called alkyl halide. CH3, CH2, Cl. Finish. That's all. Now what is remaining? 1 oxygen. Here 1 oxygen. Here 1 sulfur. Totally we can say that is SO2, sulfur dioxide. This is a gas which is eliminating, which is to be, we can represent it by upward aroma. Elimination of gases and liberating of gases. Evolving of gases. That is plus. Here 1 chlorine and here 1 hydrogen. Totally we can write 1 hydrochloric acid. Now what is our aim? Preparation of alkyl halides. What is the type of alkyl halide? This is ethyl chloride. That's all. This is ethyl chloride. Next we are going to see here the next 6th method. The 6th method, that is from alkenes. Sixth method, that is from alkene double bond compounds. Alkane is single bond, kene is double bond compounds. This is alkene is nothing but it is unsaturated hydrocarbon. Unsaturated hydrocarbon. What is this unsaturated hydrocarbon? You write now CH3, CH double bond CH2. You see, double bond is present, which are called ene. How many carbons are here? 3 carbon. So which is called a prof. Double bond is there? E. Where is the position here? The double bond present? First carbon. 1 propene. Otherwise, which is called propylene. It is common in propylene. Now I treat with this HCl or HBr, any types. That is what you can write HBr. I suppose we take. These reactions are taking place in 2 ways. One is called Margonic. This is a scientist name. Margonics. Margonicus. This is next one is anti-Margonic. Anti-Margonics. Margonic is nothing but this reagent is having ability to produce H plus and minus, that is Br minus. Actually, all halogens are, this is, we can represent it as F minus, Cl minus, Br minus, I minus. These are all more electronegative, that is negative charge, electronegative, and also which are all negatively charged species, negatively charged, and also which is having more electron affinity after gaining 1 electron, after gaining 1 electrons, after gaining 1 electrons, after gaining 1 electrons, which all become as F minus, Cl minus, Br minus, I minus. Due to its electron affinity, loving, electronegativity, it is attracting property. That's the point you should understand. But here this become as minus, and what happened here? This is negative species. Will approach us to the, now this double bond also can shift over. One that is to be positive charge, which is to be shifting out this also to be an electron. The bond is nothing but it is an electrons, pair of electrons. This pair of electron is shifting towards this carbon. And here, if the electrons is withdrawn by this carbon is withdrawing these 2 electrons, what will happen? The deficiency of electron for this carbon, it becomes deficiency means positive charge. Excess means negative charge. Now what will happen here? This is negative charge. You know, this negative charge will approach us to the fewer hydrogen carbon. You see, fewer means less hydrogen carbon. Here you see 3 hydrogen. This carbon containing 3 hydrogen. This carbon containing 2 hydrogen. But this carbon only containing only 1 hydrogen. So this carbon is called fewer, less hydrogen carbon. That is, Margonic told that fewer hydrogen, negative part, will approach us to the fewer hydrogen carbon. Now the product formed is called, this H plus is approaches to this negative charge. Now the product formed is called, we can write CH3, CH, Br, then plus CH3. Now what's the product is this? There is no side product which is we are obtaining. Why? Because HBr is simply added. This is simply we can say addition reaction. Now this is added. Finally, what's the product obtained is there is isopropyl bromide. Bro means that bromide. Now I can go for anti-Margonic. What is anti-Margonic? This is the Margonic derived products. The anti-Margonic product, why not? The scientist thinking about why not the product which is found in terminal carbon? Why not this bromine is attached to the terminal carbon? If that bromine is going to attach with this terminal carbon, it is against the margonic. That is why we say it is anti-margonic. This against the margonic. Margonic stated that the negative part will approach to the middle carbon, namely it is fever hydrogen carbon. But the anti-margonic is nothing but why not this negative part will approach to the terminal carbon. If there is a negative part will approach to the terminal carbon, the product is changed. That is a new product. That is what? CH3, CH2, CH2, Br. This iso, now this is N profile bromide. N profile bromide. Now the product is N profile bromide. That's all. So this is against the margonic, so it is called anti-margonic. But this product is not obtained at simple methods by using peroxides. Peroxides. You are using peroxide. Anti-margonic product is forming by using. There is no peroxide. Normal reaction is taking place. Now this margonic product is obtained. This is a simple concept. But here, what is our aim? Preparation of alkyl halides by using alkyl. This is alkyl. Now we are preparing alkyl halides. This is isopropyl bromide. This is N-propyl bromide. Both are possible. This iso is possible with margonic, and the N is possible with the anti-margonic. That's the point. Next, we are going to see the seventh method. The seventh method is based on the concept which is based on there is free radical substitution reactions. First method we prepared from alkene. Now we are using that is from alkane. Sixth method is from alkene. A means to take methane. See here CH4 is we can written as for our convening. We can write it as CH3 bond H. Next way we can go for this is the substitution reaction. That is substitution reaction. Substitution reaction. Now you see CH3 bond H plus chlorine. Now you take here this chlorine can split as Cl bond Cl. What will happen here? This Cl is reacted with the hydrogen. This is HCl. Now this chlorine is substituted. That is substitution. Instead of hydrogen, what is substituted? Chlorine is substituted. Now the product formed is called CH3Cl plus HCl. That's all. The first substitution over. The second method, you write now the same thing. CH3, then Cl. This is methyl chloride. Methyl chloride. Then plus chlorine. You take Cl2. Now the product is same thing. You see, first one hydrogen is replaced. Next another hydrogen is going to replace. Now what happened? Two hydrogen. This reaction takes place in presence of sunlight. Now the product formed is called, we can write CH2. Here three hydrogen is here, one hydrogen going to replace. Then Cl2, then plus HCl. Next you take now CH2, Cl2 plus Cl2. The same sunlight. The same sunlight. The reaction takes place. The chlorine is going to split as Cl bond Cl. Now this one hydrogen is going to react. Now what's the point? Now one hydrogen with one chlorine, we can write HCl. Then what is here? CHCl3. Next the CHCl3. This is called methyl chloride. This is called methylene chloride. This is called chloroform. This is called, we say, chloroform or trichloromethane, monochloromethane, dichloromethane. This is methyl chloride. This is methylene chloride. Methylene chloride. This is trichloromethane, is nothing but chloroform. Now the same chloroform I can take. That is what? CH, Cl3 plus Cl2 in presence of sunlight, the same H mu. What's the product is obtained? CCl4 plus HCl. This is carbon tetrachloride. What's the name for this carbon? It is best solvent. It is best anesthetic. That is the point you should understand. This is carbon tetrachloride. Tetrachloride. This carbon tetrachloride is used as a solvent. It is used as a solvent. The point is, now we are going to see the next method. What is that? Reactions. If we are going to see here, halogen exchanging methods by using Wilkinson reactions. By using Wilkinson reactions. By using Wilkinson reactions. By using Wilkinson reactions. That is the eighth method. Wilkinson reaction. This is halogen exchanging method. Halogen exchanging method. That means what is, instead of one halogen is present in, suppose I take for example, I take ethyl bromide. That I treat with that ethyl bromide with sodium iodide. What will happen? This sodium, this bromine is react with the sodium, and here the bromine is having more reactivity and more reaction ability with that sodium rather than that of iodine. Now the iodine is going to substitute here. Now what's the product we can expect? That is, you see, CH3, CH2I plus NaBr. This is what? Ethyl iodide. Ethyl iodide. This is what? Ethyl bromide. Ethyl bromide. That's all. Next is the ninth method which we are going to see. Here by just exchanging. It is also alkyl halide. It is also alkyl halide. Suppose we are having methyl bromide or ethyl bromide. We can use NaI, immediately we can get. Suppose we need this one, we can exchange this halogen, we will get this product of what is that ethyl iodide from ethyl bromide. This is a reaction which is to be experimentally proved by the Wilkinson. This reaction is followed by SN2 mechanism. What is SN2 mechanism? Nucleus, S for substitutions, N for nucleophilic substitutions. This is I minus, you know, this I minus is called nucleophile. See, Br minus is called nucleophile. Instead of one nucleophile, this is one nucleophile. Instead of this nucleophile is substituted. That is nucleophilic substitution reaction. That is nucleophilic substitution. Why it is called 2? This 2 represent by 2. This nucleophilic substitutions is the rate of the reaction is depend on this substance and this substance. That is, we can write substrate. This is substrate. The rate is directly proportional to substrate, and there is iodine we have used here in this reaction, sodium iodide. So the reaction rate means speed of reactions. The speed of the reaction is depend upon the two molecules are called two, that is bi. This is nothing but we can say bimolecular nucleophilic substitution reactions. Bimolecular nucleophilic substitution reactions. Next we can go for the next method of preparations. What is called the Swartz reactions. Swartz reactions. Swartz reactions. Swartz reaction. The Swartz has invented the same halogen exchanging method. It is also halogen exchanging method. Now here the Swartz we can prepare. There is alkyl fluoride. Alkyl fluoride. alkyl fluoride. From alkyl halides, from alkyl fluorides from, this is from alkyl halides. Alkyl halides. I take now, what is the alkyl halide? Just I can take CH3, CH2, Br. This is ethyl bromide. Ethyl bromide. This ethyl bromide is treated with a, what's the reaction? Silver fluoride. This is metallic fluorides. Metal. This is metallic fluorides. Metallic fluorides. Here also the same thing. Silver can become as silver plus. Fluorine can become as F minus. This is two forms as Br minus. Now if F minus approaches to here, now the product form is called, we can write CH3, CH2, F, then plus AgBr. Silver bromide is formed. This is what you say, silver bromide. This is what? Ethyl fluoride. Ethyl fluoride. It's a point. Next to the concept, we are going to see here the next method. What is called Hans-Dicker reactions. Hans-Dicker reactions. Hans-Dicker reactions. This is the last method. Hans-Dicker reactions. The Hans-Dicker is a scientist has prepared. That is that any alkyl halides. You take any alkyl halides. Alkyl halides. Any alkyl halides. What's the alkyl halide? You know that. Now he has prepared the alkyl halides from ester. What's the ester? You take for example CH3, CH2, COO, there is Ag. This is silver, this is propionic acid and its derivative. That you know propionic acid. What is the propionic acid? CH3, CH2, COOH. This is propionic acid. And its derivative is called silver propionate. Silver propionate is treated with a, that is bromine Br2. This reaction takes place in presence of carbon tetrachloride. That is, the reaction is reflaxing. You know that what is reflaxing? Reflaxing method is nothing but there is a reagents we have taken here, and here to be the round bottom flask. You can take the round bottom flask. There you can take, there is a substances. It's all substances. You can take it here immediately. This is that heater. Then you heat for some times. This is the material which is heated. Then it get evaporated. And here it is to be again back the same degree. What is evaporated material? Get back to here. It is into these solutions. Like it is reflecting for some times. Immediately the product which is formed is called, we can write what is ethyl. This is ethyl group is present. This forms a CO2. This Ag is react with the bromine. Now the product formed is called, that is what? CH3, CH2, Br. Then plus carbon dioxide evaporated. This carbon dioxide is evaporated. Then plus silver bromide. These are reactions. Here two bromine is present. One bromine is formed as ethyl bromide. Ethyl bromide. That's all. Another one forms as a silver bromide. This is the point. And here the simple methods we are using for this refluxing with a carbon tetrachloride. The reagents which we have to add here is reactions. Next we are going to see here that is physical properties. We are going to see, we have prepared all kinds of alkyl halides. We can go for physical natures and physical properties. Physical properties. First method. First we have to when it is exposure to light, when it is exposure to sunlight, that will produces color that the bromine will use, that is bromine Br2 will use a brown color, and iodine also to be colored. This is a point you should understand. Next that we are going to study about nature and state. State means what is the state of these compounds. Generally, these are all 3-carbon alkyl halides, up to 3-carbon alkyl halides like methyl chloride, ethyl chloride, propyl chloride. These are all to be in gaseous state. That is gaseous state. More than 3-carbon. More than 3-carbon, which are all to be in the solid or liquid state. Liquid state, which are to be solid and a liquid state. Then thirdly, we can go for what's that? Boiling point and a melting points. Boiling points and a melting points. Just you should go for this, what is that? Boiling point and a melting point. The boiling point and melting points. Generally, melting points. See, the methyl chloride is having greater boiling and melting point than the first point. It's derivative of hydrocarbon. Methyl chloride is prepared from hydrocarbon, so which is only having greater melting point and boiling point. What's the reason for its melting point and boiling point? Because of its van der Waals forces. Van der Waals forces. Van der Waals forces, and also which is having more van der Waals forces, and also which is having more dipole interactions. More dipole interactions. Van der Waals forces is nothing but there is a forces which is existing in all kinds of organic compounds. That is, see, the force which is existing between these two carbons, this is Van der Waals forces, is more in this case of alkyl halides. Dipole moment is nothing but you should write your CH3Cl, which is to be del minus, which is to be del plus. These two charged species is having its interactions, that is dipole-dipole interactions, is more in this case of negatively charged and positively charged. That's why it is having greater boiling point and a melting point. Greater boiling point and a melting point. The next point, what you want to understand here, and then melting point and boiling point, which is to be more for this case of melting point. Pagal? Melting point and a boiling point is more in this case of methyl iodide than methyl bromide. then methyl chloride, then methyl fluoride. Fluoride. Why? Because which is having more size and higher atomic number. Is having more boiling point and melting points. Next point you should understand here. The boiling point increases. The boiling point is more in this case of carbon tetrachloride. Same one carbon, chloroform. Same one carbon, then methylene chloride. Same one carbon, then methyl chloride, one carbon. Even though which is having the same number of carbon atom, but whose boiling point and melting point will be melting point and boiling point will be greater for this. More chlorine is here. So which is that more molecular weight? Molecular weight is greater, and here that chlorine is more and more. So that boiling point and melting point and boiling point will get increases. The point we should understand. Next to the melting point and boiling point is also increases with the increasing number of carbon also. For example, you take that is butyl chloride. You take for example butyl chloride. There is 4 carbon. Molecular weight is more. Then profile. You take propyl chloride. That is 3 carbon. Now you take that is ethyl chloride. There is 2 carbon. You take methyl chloride. There is 1 carbon. There is 1 carbon. Now, which is having more molecular weight, which is having more molecular weight, more melting point, and more boiling point. The point you should understand. The next things you can go for this. What is the increasing surface area also increasing this melting point and boiling point. What is surface area? You should understand. I take here that N profile chloride, and here this I can write it as isopropyl. This I can write it as melting point and a boiling point is increasing with increasing surface area. Surface area is more for 4 carbons. Now I take that isopropyl. This is N-butyl. I take isobutyl. I take after that I want a tertiary butyl. You see. But here, see, this also containing 4 carbon, this also containing 4 carbon, this also containing 4 carbon. But the surface is more, so more melting point and boiling. Surface means the occupying space is more, but this occupying space is less. This occupying space is very less. It is equal to methane section. You see, that's why which is having less boiling point and a melting point. The surface is changing, the melting point, boiling point also changing. Like that, we can go for this concept. Next, we are going to see what is solubility. Solubility. That the alkyl halides, you see CH3Cl is not dissolving water. Not dissolving water, no reactions. I take the methyl chloride. I can take the chloroform or carbon tetrachloride. This is carbon tetrachloride. I take chloroform. This can able to solve. This is dissolve into these organic solvents, which are called organic solvents. Which are called organic solvents. Organic solvents. So organic compound are dissolving into organic solvents. Organic solvents. The point. This is inorganic solvent. Inorganic solvent. It is polar solvent. not dissolve. This not dissolves this organic compound. The point is here, right? But also this cannot form hydrogen bond with the water. Cannot form hydrogen bond with the water. This is not forming hydrogen bond with the water. So that's why this alkyl halides are not solubly in water, whereas these alkyl halides are solubly organic solvents like chloroform and carbon tetrachlorides. Next, the things solubility are very clear. Density. We are going to understand about the point. What is density? The last point we are going to see what is density. What is density? Actually, the alkyl halides are having more density than that of hydrocarbons. That means what's the point you should understand? Methyl chloride is having denser than that of methane. Why? Because methane, the methyl chloride is derived from methane, but which is also containing one carbon, but which is having more density. Density is more rather than that of this compound. That's the point you should understand. Next to the point, so an example question is given in our book. What the question which is given in our book is, that is C5H11Cl. C5H11Cl. What are the possible isomers? You see, I can write 5 carbon. You see, CH3, CH2, 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 then CH2, Cl. This is N-pentyl. That's all. Now I am going for this. CH3, CH3, CH2, CH2, Cl. See, 1, 2, 3, 4, 5 carbon is here. This is isopentyl. Next, you see here the next concept. After this N-pentyl and isopentyl, next we can go for secondary pentyl. What is secondary pentyl? You see, CH3, CH, Cl, CH2, CH2, CH3. This is isopentyl. Sorry, it is secondary pentyl. This is secondary pentyl. Secondary pentyl. The halogen is present in secondary carbons. Next way we can go for tertiary pentyl. Next we can go for tertiary pentyl. This is tertiary pentyl. Why it is tertiary pentyl? Because this carbon containing, this is to be a tertiary carbon. You see, this is one alkyl or this is one alkyl or this is one alkyl or 3 alkyl with 1 carbon. It is tertiary group. It is tertiary pentyl. Next to the concept, you can go for what is neopentyl. You see, this is what the structure: CH3, 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 CH2Cl. This is the concept you should understand. 4 alkyl, 1, 2, 3, 4 alkyl are present in 1 carbon atom is called neopentyl. So these are all the structures which are possible for C5H11Cl. First structure I have given what? N-pentyl. Second structure what I have given? Isopentyl. Third structure what I have given? Secondary pentyl. Fourth structure I have given tertiary pentyl. Fifth structure what I have given? Neopentyl. These are all the possible structure for this. What is this? See, find. Likewise, you have to approach the questions, and you have to see that what is the concept which is given above, and you have to study about this. What are the fundamentals, learning point which is given above? You have to gain more knowledge, and you have to do this all the concept. What is we have studied today? Simply we have studied today only the preparations. That you know this we have studied in this alkyl hydrocarbon lesson also. You please go through this all the concept of this preparation. Differently, we are studying about Wilkinson, Sparks, and Speaker reactions only. These all three reactions are very important for the entrance point. Then we have completed the physical property. What is the physical property? And we have nature of the substance and what is that the state of the substances. This all we have completed. And what is the solubility? And what is the characteristics of the solubility? And what are the melting point and boiling point, and which is the substances having more melting point, boiling point. These are all the points we have studied. You please go through very properly.